Well, that was a very long half hour. It's now 3 days later. The capacitor appeared to be repolarising reasonably well to start with. The voltage was climbing steadily, with the original resistors at 330k. The voltage got climbed to about somewhere around 80-90 volts before it stopped. So I changed the resistors down to 100k. It gradually climbed again. That got it to somewhere around 180, I believe. Then 47k, up to about 250. And it's presently on 10k, and that took it up to 310 volts. Each stage took several hours. I mean, probably on power for about 2 days overall. But after it had been sat with the 10Ks for a couple of hours, after it got to 310 when I checked it, it was going down again. It was down to about 301, and the voltage was jumping about slightly, so I was a bit concerned that something was breaking down. So I just shut it down and left it at that. It's now been off for a day. I'm just going to try putting power again and see if it's gone up or gone down. But it is looking like the capacitor may be beyond salvage. I'll find the socket down there. Okay, let's see what the voltage is doing. Here's a different point. Ah, now that's a good sign. A very good sign. It's straight back to over the voltage it was apparently starting to fail at. That's what I was hoping. After letting it stand for a while, and the chemical effects in the battery settle, it would start to improve more. And that seems to be what's happening. The only other thing I'm slightly concerned about is that each of the transformer windings reads 288 to 290 volts. So the rectified voltage is going to be near 400. That's not allowing for the voltage drop in the rectifier valve, which could be considerable. And the capacitor is only rated at 350 volts. But looking at the way that's going, I'd say it may be fully functional at that. So the next stage is to try the rectifier valve back in and see what voltage it gives with the valve. I'd say that's looking good. There's obviously still some leakage, but it's a tiny fraction of what it was when I first turned it on. You know, at the start of this video it was only showing about 10 volts with a resistor from 350 volt supply, or 350, 400 volts. Yeah. Now, I'm happy with that. Now it's going up again. I'm going to put the valve in. Put the volume knob back on. Oh, the other thing I've discovered, just thinking the volume control pot here, is that the original dynamic microphone and speaker I tried to use with it as a teenager when I was playing with the thing probably would not have worked at all as well as they should have done, because the output goes from the wiper of the volume control pot, and from the schematic you can find it, the volume control pot is 1 megohm, so it needs an exceptionally high impedance speaker or microphone onto that, because the microphone circuit, when it's switched to record, goes back into the top of the pot. So I'm guessing the original units were actually crystal, so very high impedance. In the meantime, on eBay, as I thought that capacitor was going to fail, I have bought a new capacitor for it, but it may not be needed, which is a good thing. I'm not complaining. Oh, the other side, I've also got some Bakelite polish to try and get the scratch out the lid. Having done a bit of research, apparently a fine scratch like that will just polish out, and it should be literally as good as new once it's had a good polish with a abrasive polish. Anyway, I've been talking whilst this discharges because I don't want to touch it whilst it's got 300 odd volts DC on it. So I'll try that again. Let's see if it's gone down a bit. Yeah, it's below 10 volts. That's fine. So I can pull that out. That's the diode and resistor setup. And that, hopefully, is the rectifier. Check the schematic again. No, wrong one. The rectifier is a 6X5. That's a 6SL7. No, I think I've turned the box round. Thought I've got them in order. But they're in the reverse order. 6X5, there we go. On dual diode rectifier tube valve. Been reading too much American stuff by the sound of it. That's not got the glass cemented into the envelope. The glass envelope cemented into the base rail. It wobbles slightly, so you want to be very, very careful with that. Don't damage the wires. Be nice to be able to see all the bits of this at the same time and get to the capacitor, but well, the mains cable coming in like that, it's a bit awkward, and this cable is still alive, so I don't want to touch anything. Oh, we've got the filament glow. Just turn the bench light off. You can see the filament's alive in the valve. That's the unit's power lamp that's giving the glare. No, it's now standing on the valve itself. Just a box I was using to balance it. Okay. See how the rectifier works. Now there's no load on it at the moment, because the valves aren't in. Lots of oxide on those. Almost 300 volts again. So the valve is obviously dropping the supply somewhat. Okay. Try the other valves in so it's got some load on it, I think. I'll wait until it's down to a reasonable level before I touch anything, so I'll move it about around just in case. As 50 volts or above is enough to be annoying, at least, to put it mildly. And the 300 and odd volts would definitely be unpleasant. Okay. Not to be intending to zap myself, but you never know. I'll stand that way. Okay, the middle valve according to the schematic is a 6SN7. I'll pick the right one this time. And the preamplifier is 6SL7. Every time I look at this thing, I'm more impressed with the overall design for the time. But I suppose, in hindsight, 1950s, or this actually the one of the things in this is dated 1950, which sets the time it was made. Valves can be slightly microphonic. So vibration can affect the sound going through and will be picked up, like a capacitor microphone, as the elements within the valve vibrate. The preamp tubes mounted on I keep calling them tubes. The thermionic valves. Reading too much American material. It's mounted on grommets, so it's rubber isolated from the chassis to try and reduce the vibration pickup. Though the rubber in the grommets is fairly hard and a bit perished. Also, remember this was pre-tape recorders, it has a bias oscillator. There's a Colpitts oscillator circuit which has its output mixed in with the audio from the preamp and into the recording head, recording and playback head. So when it's on record mode, the signal path, part of it's from the part that the third stage, could call it a power amplifier, as near as it's got one, although it's only milliwatts I would think. The power amplifier through that capacitor into the head, and the bias oscillator through that capacitor into the head. So the bias oscillator is ultrasonic and makes the recording much more linear, much better quality. It overcomes the hysteresis of the tape material, or the magnetic material, should I say, it's not tape, which I thought was a newer innovation than that, but obviously this is ahead of its time. Man, I keep saying that. 1950, these valves were invented somewhere around the turn of the 20th century, I think. So this is not long before transistors started to take over. So it's probably getting on for a kind of late generation, state-of-the-art piece of equipment for its time. You know, it's got 50 years of advancements behind it. So I shouldn't really be all that surprised. It's pretty well designed. Anyway, I've got all the valves in. Oh, it's a bit unstable now. It's unbalanced. There's that little box again just to steady it, I think. Oh, that doesn't fit now. Oh well. Just have to hold it. Okay. Power cable. Switch on. And with the cable attached, it steadies it a bit. Trying to get things visible again. Untangle the meter leads. Oh, that's reduced it a lot. But that's now down to the active load of the other stages. You can see it's gradually climbing again. Very slowly. But that's a good thing, because it means the capacitor should be within its official rating of 350 volts, which I was a bit worried about before, because I didn't know how much drop there was going to be across the rectifier and the load with the load on the transformer when it was working normally. Just check the transformer voltage now. It's a sensor tap winding, 2 diodes in the rectifier valve for the output. So it's a split full wave rectifier. Still around 280 something volts. So it's not loading the transformer voltage down a lot. A bit. It's come down from 290 to 283 or so. Yeah, it's reasonably symmetrical. That's the other end of the sensor tap winding. All the valves are flowing nicely. On the good side. Yeah. Critical support box. Just reduce the lighting a bit here. They're all 2-element valves. That one's got the 2 elements stacked one above the other, whereas the audio valves have the elements side by side. Lighting back. Right, so that looks very promising. I think the next thing is probably to replace that DIN socket with the proper Jones socket. Jones connector. So that's to go in place of that temporary DIN socket I put in as a teenager a few decades ago. There is one other bit I need to test, and that's the circuit for the solenoid for the pause system. That has its own selenium rectifier. Oh, interesting. Now I get a different light coming on when it's turned supposedly off. Oh no, sorry, that's the record playback switch. I've got it backwards. That's better. That would explain the on behaviour. Yeah, let me move that out of the way very carefully so I don't repolarise myself. Grab the base unit casing. I've got the idler wheel back in. That seems quite reasonable. It's not perfect, but it's got a lot better surface than it did have originally. Now that's the pause system. It's an arm on a solenoid that just pushes the idler wheel away from the motor shaft with a almost knife-like edge, so it stops the thing instantly and allows it to start again quickly. Well, this is pause play. When it's being used as a dictaphone for the secretary listening to it and transcribing it, it allows them to stop it as they work. But that system is fed from a selenium rectifier. Now, selenium rectifiers are well known for degrading over time. Now, according to the diagram, that has, in the version for that diagram, it has a single diode and an electrolytic capacitor in the circuit for the rectifier, for the solenoid. This has a full wave selenium bridge and no capacitor. I mean, it'd be nice if the rectifier does work, but it's a bit dodgy as it is direct on 240 volt supply that goes into the machine. So that is going to have to be tested carefully. I may leave it in and just discreetly put a modern bridge somewhere nearby if there's a fault with it. I mean, they often show signs of the coatings peeling and flaking if they are degrading. I mean, they sometimes look very, very patchy. Now, that has no visible problems. Ah. That's something that needs checking. That's got an earth wire from the bridge. Now, I wonder if that is directly on mains then, or if it comes off the transformer. I'll have to check that. The other diagram may be for an American version that works on different voltage. It may be transformer fed rather than direct, because I cannot believe they've got a rectifier connected to mains ground from main supply, because things would tend to start smoking and going bang. So that's the next step, is test that, and no, next step after the microphone socket, should I say, is test that and see if it's still usable or not. Oh, regarding the microphone, it's another bit. I've found some new strap parts to replace the very, very rusty and degraded strap, a new black leather strap. It just happens to have exactly the same sensors as this, which is quite convenient. Okay, that's it for this one, and I'll carry on.